Part 3 says, hence solve this quartic equation. So that's a power 4 function. So to solve any sort of equation of this form, I would complete the square. I wouldn't worry about this is that this is power 4 and this is power 2. That's equivalent for the first part of the question to this. So we could work with this instead. I'm just going to work with x to the power 4 and deal with it as we go through it. So, but the method I would use is completing the square. So I'm going to write down x squared, take away half of this value, so that's 5 squared. And then I'm going to take away the square of this number. And that is equivalent to x to the power 4 minus 10x squared. If you expanded it and to check, you would find that they're the same. We've then got this plus 169, and that equals 0. So we've got x squared take 5 squared plus 144 equals 0. So if we start rearranging this to get x on its own, that's going to be x squared take away 5 squared equals minus 144, which, when we square root it, will be plus or minus the square root of negative 144, which is 12i. So x squared is equal to 5 plus or minus 12i. So x is equal to the square root of that. But we've already worked out the square root of 5 plus 12i. That's 3 plus or minus 3 plus 2i. So all we need is the square root of 5 minus 12i. But we've already shown that 3 minus 2i squared is 5 minus 12i. So if we were to square root this, we would get 3 minus 2i. But we would also get that same expression if we had minus this squared. Or in fact, sorry, if we had minus that squared. So minus 3 minus 2i is also a solution. So we've got plus or minus 3 plus 2i or plus or minus 3 minus 2i. So that can be written as plus or minus 3 plus or minus 2i to show all 4 solutions.